Hey guys, welcome back to Last Stop Repair Shop. My name's Fran, and on this episode, part 2 of a 2-part series, we're going to show you guys how to test and troubleshoot the cruise control module underneath the hood of your GMT400 pickup truck. Let's get to it. All right guys, so real quickly here I want to talk about this DRAC module that I've got in my hand here. If you guys have the 4L60E, if you guys have the 4L80E transmission, E is being electronic, right? Those transmissions are electronically controlled, and you're going to get that 4,000 pulses from this DRAC module. All right, this guy can be found underneath the glove box. So you pull the glove box out of the dash, and right underneath of that, you'll find this DRAC module plugged into a wiring harness. Those of us who are unfortunate to have the 700R4 transmission are not going to be this lucky. So all of our signal conversion is done in the instrument cluster. But I wanted to talk about this real quickly because if you guys did the testing from part 1, you know, you tested for all your voltages and you've got them. You tested for your 4,000 pulses per mile signal going into your cruise control module, and that was erratic. It was all over the place, wasn't stable like you've seen in the video in part 1. Then chances are, if you've got that 4L60E or the 4L80E, you've got this guy. This is the thing that's in charge of converting that signal from the transmission to something that our cruise control module can use. So lucky for you, this is easily changed out. You can get these online, you can go to the Evil Bay and get them. I believe there's even a company on the interwebs that is refurbing these and offering them at a pretty reasonable price for what it is. So these are readily available and easy to come by. Anyway, I just wanted to point this out quick. If you do replace this, you do have to calibrate it. There is a calibration procedure for this. It is available online. I'm not going to go into it in this particular video because I don't have a vehicle that has the 4L60E or the 4L80E. Ours has the 700R4 in it. So for me personally, I don't have a vehicle to test this on, but I do know this is a thing for you guys that have the electronic style transmissions. But nope, we got the 700R4, old school, mechanical, hydraulic, no electronics. Sometimes that's a good thing, and sometimes it's not, right? It is what it is. So anyway, just want to talk about that real quick. All right, folks, here we are at the testing part of this here video. And if you guys watched the first part, we went pretty extensively over the wiring here, didn't we? And what colors went to what? Again, as I said earlier, if you guys didn't watch the first part, I really strongly encourage you to do that because we did cover a lot of this already. But if you didn't and you don't want to, I get it, all right? Time is money. That's understandable. So we can go over the colors here again really fast and just briefly kind of touch on them as to what wire goes where. So the pink wire came directly from the key. So as soon as you turn the key on, this wire here goes live immediately, right? And then that wire also feeds your stick on the column. The on-off switch was gray. The brake switch was brown. So these three should always be energized unless the cruise control's turned off, right? If it's turned off, you'll only have live on the pink and nothing on these two. As soon as you turn that on and your foot's not on the brake, the brown will be energized from the gray, which comes from the on switch on the stick on your column. So all three of these we're going to tie together. That's positive. All right. And then if you guys remember, the black with the white stripe, that's our ground. Okay. So, and then the blue is your set. The green is going to be your resume switch, all right? At no time in the operation of this cruise control module will these two be energized at the same time. If they are, it isn't going to work. And then your brown with the white stripe, that's our square wave going in, okay? So to test this guy is really easy. Yes, I did pull this harness out of a donor truck, just cut the harness off. We had a truck that we scrapped out. I thought, hey, it'd be a good idea to cut that plug off the harness, and then we've got it for testing. And I'm glad I did it because it's coming really handy. So you don't have to hack the truck that you have in order to do this. Just go to the junkyard. Go to the junkyard and cut one out. They'll probably charge you $2 for it or something like that. Not a big deal. Okay, so we're going to go ahead and hook this up to our battery. We got the pluses over here. These guys are always positive, never negative. And then we've got the Debbie Downers over here, the negative. So, all right, that powers this unit. This unit is now energized and powered up, okay? So, now, the next thing we need to do is use the audio generator here. You just need something that will generate a frequency, all right? A frequency with an output amplitude of, you know, 5 or 6 volts, something like that is all you need. Polarity doesn't really matter here because we're dealing with an AC waveform, right? Yes, that's what we're doing. So we'll hook that onto our negative, and then our this other wire here will go on to our signal input. This generator here, as you guys can see, this generator here will show us that it can do square wave as well as sine wave, all right? And I'll show you the difference between the two of those on the scope here in a minute, so you guys kind of get an idea of what it looks like, but I wanted to show you that. This thing's essentially ready to roll. So now what we're going to do here, I'm going to start out with the Fluke meter, and if you guys have one of these, all right, it doesn't have to be a 177, it doesn't even have to be a Fluke, but what it does have to have is hertz and volts AC. This is what it does have to have if you want to be able to see this signal. The hertz are going to be very imperative to actually see the signal. The volt AC is going to be important to tell you how strong is the signal, what's the amplitude of it, right? Is it very weak and that's why it's not working? It's there but it's weak, or is it super strong? So that's what that's all about. So you want to make sure the meter you're using has the ability to do AC and hertz, all right? Same thing, one side of this is going to go to negative, all right? So we can put the one side of this this meter on here with the signal. We want to read the signal going into the unit is what we're trying to do here. All right. So we'll start out with it in AC. We'll turn the generator on. So we're generating a signal now, right? And you can see here, looking at this, it's about a 5.7 volt signal coming off of our generator here. All right. So now if I hit the yellow button, that takes me to hertz. You can see that's reading a solid 626.3 hertz. All right. So we're going to go ahead and slow this down. We don't need to be ramping it up nowhere near that fast. Might actually have to get down in another range here. So there you go, that's more like it. So there we're reading 27, 28, 30 hertz, all right? 30 hertz. So 30 hertz is, our signal is cycling from negative to positive 30 times a second. Every second we swing from negative to positive 30 times. That's what hertz means. So right now our button is out. So we're actually sending a sine wave to this. If we push this to square wave, which is what this guy is really looking for, is a square wave. We won't see any difference on this meter here. That's the glory of an oscilloscope, is it will actually show you the signal. You can actually see the signal in real time. With this you can't. You can just see that there is a signal. You can't see if there's noise on the signal. You can't see if there's if it's a square wave or a sawtooth or a sine wave or whatever. You can't really tell the type of signal it is. You can just tell how many times it cycles from negative to positive in a given time period, right? So that's all you're going to see here. Which, for most people, this is all you're going to need to tell whether or not it's actually working out in the vehicle and whether or not this unit is actually working here. Okay. With that having been said, I'm going to lay this down here, and hopefully one of the cameras I have operating here will be able to see it. And I'm going to go ahead and take this blue wire, which is our set wire, and I'm going to tap it to the positive post, telling this unit that I want it to set the cruise speed. And you should hear it click, and it'll pull in a little bit of cable like that, just like it did, if you guys noticed that. So now this unit is set to that speed right there. As I adjust, I'm just going to put a little bit of pressure on this so it doesn't get all wrapped up inside there. As I adjust my hertz up and down, you'll see this cable go in and out. And that will tell us positively this unit is functioning the way it's supposed to. All right? So if we increase the hertz, it's going to pay me out some wire here, right? It's going to see how the cable's coming out real slow. And that's because if you think about it, in the vehicle, when you're rolling down a hill with the cruise control on, we need less RPM, right? We need less speed because we're gaining speed rolling down the hill. Gravity's working for us. So it's letting off of the gas. It's letting off the foot feed, right? To slow the motor down. Now, when we start going back up the hill the other side, what's our hertz going to do? It's going to go down, right? Because the vehicle's going to slow down. So as the hertz goes down, we start pulling cable back in, which would be pulling on the foot feed to accelerate. That's how these old vehicles work. That's how the cruise control worked on them. It's really pretty darn simple. And pretty impressive, to be honest. They figured out how to do this back in the day. Granted, this vehicle's an 89 that we're dealing with here, but you know, this isn't a new thing. Even in 89, they had cruise control, gosh, I think in the 50s. So it's nothing new. Obviously, you know, the cruise control back then would have been a lot more crude than what this is. But it still did the job, right? So that's basically how it works. I'm just pulling out on this a little bit and running the hertz up and down. And you can see that it continues to do its thing. It's pulling it in, it's letting it out as the hertz go up and down. That's it. That's all it does. This cruise control module is functioning the way it was designed to function. It works. So we've tested it. We know this thing works. We're good to go. Got this little cheapy oscilloscope here. I'm going to show you guys what this looks like. So there you go. Hopefully you guys can see that. That is our square wave. Granted, it's as I said in the truck, it kind of looked the same way, not real square. If you guys watched part one, you noticed that we kind of had the same thing going on out there, and I suspect it has something to do with this cheapy O-scope. It could even be a setting in this thing that I'm not overly familiar with this unit. I know enough to be dangerous with it, so if we change the range here, you can see, as I showed you guys out there, that change the range here, you can see where at 5 volts it makes it a lot bigger, right? And then if I change this down to 2 volts, well, now it's huge, right? It's full scale. So try to keep it within range so it's somewhat reasonable and easy to see. So what this thing will allow you to do is see the signal in real time. And what it will also do is show us, as we change the frequency, we can see the waveform get smaller and bigger. See that? How it's getting closer and tighter? And that's because the frequency right down here is going up. Right? As I'm turning this up, the frequency is going up. So this is a really good tool to help you guys see the signal and exactly what it looks like. So this is set for square wave. Now if I go over here and change this to sine wave, see how everything rounded out? It's still a signal, it's still showing us the same hertz, but now it's rounded, it's not square anymore. And that's a sine wave. So that's what a sine wave looks like. Sine wave, square wave. This procedure I'm showing you guys is only going to work on this unit right here, this 2507-4400. I have some newer units that I had gotten from the junkyard off from, I think it was a 96 van or something like that. And the thought process was, hey, if I pull one of these off of a newer vehicle, it'll have less miles, right? It'll be newer, it'll be better. Well, that's fine in theory, but it doesn't work with this setup. So they're doing something different. While it looks the same as this unit in my hand, it looks identical to it. The plug even has the same pinout. everything looks the same. The problem is it doesn't function the same. If you look at a plug on the newer vehicles, there's actually more wires involved, and they're different colors. So without me really going down the rabbit hole and digging deep into why that is, I honestly can't tell you. So I don't know what the difference is between it. It could be, instead of 4,000 pulses per mile, it's 8,000 pulses per mile or some crazy stuff like that. Maybe it's being fed a digital signal, data from the ECM rather than what we have going on here. That's how you test it. It's pretty straightforward on these early model units. If you are going to go to the junkyard, again, make sure you get one with that same part number on it. You can't go wrong. All right, there you have it. There's the tools, there's the meters, and the procedure on how to test your cruise control module. It's not too hard, is it? It's actually pretty easy. So one thing I am going to admit out of this video that I did talk about in part one was the modification of your instrument cluster should you not have that 4,000 pulses per mile signal going to your cruise control module. We ran into some off-camera issues, and so I don't want to put bad information out there, something that isn't going to be correct. So until we get those issues figured out and get a good plan going forward, we're not going to put that information out right now. So I don't want to set anybody up for failure. I set myself up for failure enough, so I don't want to set you guys up for failure. So I guess, technically speaking, at some point in the future, there might actually be a part 3 of this whole series, but not something I originally planned. It definitely took a different direction down another path that I wasn't planning on. So that happens. It's life, right? It happens to all of us. So I'm just glad I was able to catch it here before we put it out, to the masses. So it is what it is. So we're going to go ahead and get the situation figured out. And at some point in the future, I honestly don't have any idea when. I've got a lot of other projects in the pipe that are going to come ahead of that. So once we get it figured out, we'll definitely put together a video for you guys and get it up on the YouTube. So that way, you guys can have the information too. So, but we got to get it perfected before we give it to you. So thanks for watching. We guys really appreciate all that you guys do. If you like the videos we're making here, hit the like button, hit the subscribe button, help us grow the channel. That's kind of the goal. That's what we're after. So it doesn't cost you guys a dime, even in today's economy. So still free. One thing that is still free. So hitting the like and subscribe. Thank you guys. We'll see you later.